All right, good afternoon, everybody. My name is Vivek Chilukuri. I'm the Senior Fellow and Director of the Technology and National Security Program here, and we're very excited to close it out with the last panel of the day with Caitlin Frazer, the Executive Director of the National Security Commission on Emerging Biotech, for the battle for biopower, how the U.S. and China are competing for biotech leadership. So let me just make an observation that without casting any shade on our position in the program, I think it in some ways is telling that, a lot of times when you have technology conferences or national security conferences, that biotech always doesn't get top billing.
Yeah, it's like
right?
fourth or fifth.
Fourth or fifth.
Yeah.
And I think that's actually a great place to start, because I think it suggests that there's a lot of learning that has to happen in Washington and the national security community about why biotechnology deserves higher billing than it's been given, right? There's a lot of things competing for attention: AI, quantum, nanotechnology, hypersonics. Why does biotechnology deserve higher billing? And maybe you can tell us a little bit about what you've been doing on the National Security Commission, the report recently, and the case that you've been making for why biotech matters.
Absolutely. Thanks for the opportunity to be here. I lead the team at the National Security Commission on Emerging Biotechnology. This is a group established by Congress in anticipation of the need to legislate at the intersection of emerging biotech, national security, and economic security. Congress does this from time to time, particularly when grappling with complicated technological issues. They impanel a group of experts to look across the range of policy issues facing that technological sector and advise them back on the measures that are needed to promote U.S. leadership. So for the last 2 years, our commission has been working on a project to answer that question. Not just why is biotechnology important for U.S. national security, but what should we do to retain, or in some cases regain, the U.S. leadership position in biotech. Look, biotech is always like fourth or fifth on any critical and emerging technologies list. And I think there are a few things that I really like to emphasize when communicating about this to policymakers. The first is that this is not a particularly new technology. Biotechnology is actually one of the oldest technologies that we have, because at the end of the day, a lot of it has to do with fermentation. We have, as a human race, we have been fermenting things like beer and wine and yogurt and all kinds of things, bread, for a very long time. What is new about biotech are the tools that are transitioning this technology from a field of tinkering and testing, where innovations might represent a scientist's entire career, to a field of design, where we can more predictably engineer the outcome or output of a biological process with these increasingly available and precise tools to read, write, and edit DNA. I think that biotechnology, I'm paid to think that biotechnology is the most important of the critical and emerging technologies, but I actually believe it for two reasons. One is it is a manufacturing discipline. We make products that consumers use with biotechnology. There's a study that our commission often points to that says that something like 60% of the things that we make and use every single day can be made with biology. That's not science fiction, that's not 50 years from now, that is near-term use cases like textiles, plastics, chemicals that are critical for our defense supply chains, food, of course, medicines, cutting-edge therapeutics. 60% of the things that we use can be made with biology. Extrapolate from that the job-creating potential of this sector, right, as a manufacturing discipline, the opportunity to reindustrialize many of the supply chains that have left the United States and create really exciting jobs all over the country, not just in Boston and Silicon Valley, where a lot of the R&D happens, but in Indiana, which is our chairman's home state. Senator Todd Young leads the commission, and Indiana has become a biomanufacturing powerhouse. The other thing I want to remind policymakers is that losing the innovation and commercialization race on biotech has, in my mind, perhaps more significant consequences, higher stakes, than losing on other technology sectors. So, in our report, which, by the way, you can find at biotech.senate.gov if you haven't had the opportunity to read it yet, talks about a future scenario in which China uses its growing dominance in this field to exert control over key nodes of the supply chain, denying Americans life-saving cures, and thereby creating all kinds of economic and geopolitical leverage from their ability to weaponize things that we would desperately want and need from a healthcare perspective.
Yeah, no, that's a great answer, Caitlin. I mean, it's not hard for people to understand, for example, when AI had its moment with its ChatGPT moment, why it's a transformational technology. Because when you think about it, it's okay, anything where we use cognition or data analysis or critical thinking, regardless of its application, AI would be applicable and potentially transformative. And so for biotechnology, maybe the parallel is it's not necessarily where any place that we use critical thinking or cognitive analysis, but it's anytime we're making things, right? No matter what sector it is, whether it's in pharmaceuticals, whether it's in textiles, energy, and when agriculture, and when you think about it that broadly, I mean, in some ways that's, I think, the breadth of biotechnology has been one of the opportunities, but also the challenges in the advocates for biotechnology to make the case, because it is so far-reaching. It's everything from the pharmaceuticals to the spider silk to the biofuels to the genetically modified chicken and corn. And so as a result, I think even as a political matter, the different constituencies within the biotech community don't even necessarily see themselves historically as part of a common community, advocating for investments from Washington, investments from states, and seeing also the threats sectorally that they're facing. And you talked a little bit about what the world would look like if we lose our leadership to China, or any other country for that matter. But I think your report, and also a report that we put out in January called Biopower, also assesses China as the most likely competitor to match or exceed the United States in emerging biotechnologies if it hasn't already. And I mean, just help us understand what would the world look like, if China overtakes the United States in critical and emerging biotechnologies? Like, in terms of the practical consequences for the United States, the specific national security implications of that. Help us see that picture a little bit.
Sure. Excuse me. So maybe just to expand a little bit on the supply chain point, which is to say, we have seen China extract either licitly or illicitly the innovations across technology sectors from here in the United States and other Western countries, and then they are really good at scaling those technologies, at making things far more quickly and cheaply at scale than we are able to do here in the U.S. One of our diagnoses in the report is, and I think this was common to the Biopower report, is like we're great at innovation. We are not sufficiently commercializing those innovations here in the U.S. Some of that comes down to capital, some of that comes down to the availability of infrastructure. A lot of it has to do with the way that we regulate the products of biotechnology and get them from lab to, into the hands of consumers. But at the end of the day, China has been making dominance in this sector a strategic priority for 20 years, and that is across the capital vector, across the talent vector, I mean, really everything. Yes, it is. We should want for there to be competition and innovation, right? That makes all of us stronger. But when you see a brute force economic playbook that China, the Chinese government has run on multiple technology sectors, applied to biotech, and you think about what happens if they're able to turn off the supply of a key therapeutic, or even further up in the innovation pipeline, a key piece of equipment or enabling technology. That's a scenario that the Commission worries a lot about and that we think is very possible if we allow our historic strengths in innovation to erode, and if we don't deal with the fact that we are not very good as a country, as an economy, at commercializing this. The other thing is that biotechnology has really potentially transformative applications for conventional military capabilities. So one of the things that we highlight, we have a whole chapter in our report about maximizing the benefits of biotech for defense. And here we're talking about things like biomanufacturing, high performance coatings, and it sounds really like deeply unsexy, but when that coating is the difference between your airplane catching on fire and not, that really matters. Or the range with which you can fly, or the explosive power of a munition. Like, these are things that biomanufacturing affords us an ability to reshore those capabilities. You know, another really great example, actually, I should have brought it with me. Like, we have this bag of synthetic blood that we sometimes carry around.
It's probably good you didn't bring that with
which
you.
I brought it to my last meeting, and I like took it out and I like fumbled it, and people were like, "Oh no, like what has she got?" But the point is, right now, in military medicine, one of our major constraints is the supply of blood. We talk in a military medicine context about the golden hour after a trauma, right? This is the amount of time that our service members have to get, you know, medevaced out to a higher level of medical care. And one of those major constraints is around blood. It's hard because right now the standard is, you know, you have to have blood donations, you have to keep it cold, you have to have the right type for everybody's blood type. And synthetic blood, which is something that DARPA has been working on for some time and is really promising technology, solves the cold chain issue, solves the blood type issue, and you know, it is operator friendly in the sense that you basically like crack this thing open like a glow stick, mix it all up together, hang it, you know, like an IV bag, and you turn a golden hour into something more like a golden day. And that is the kind of potential that, you know, we would be leaving on the table. We would be ceding to a potential adversary if we lose, you know, if we don't make the kind of investments that, you know, your report calls for, our report calls for, that a lot of voices in this space are calling for.
Yeah, and we'll get to that in a second. I mean, I would like to we'll shift a little bit to talk about where the U.S. and China stand in terms of our relative strengths and weaknesses, and we've previewed some of that already. But just to take another lap on your point, I mean, a recent and perhaps obvious example, but I think one that's worth restating over and over again, is we just all lived through a pandemic, right? Mm-hmm. And if we want to think about the consequences of not having a cutting-edge ability not only to develop world-leading effective vaccines, but then to produce them quickly, right? Just imagine a world, and this is in no way to diminish what happened during the pandemic, it's just to encourage people to think about how much worse it would have been, right? We lost 1 million Americans to the pandemic. We, as a federal government, spent something like $4 or $5 trillion. That's not even including the indirect and direct economic consequences of all the shuttering. Imagine if we had to wait 2.5 years for a vaccine instead of about a year, right? Imagine if in a context of even worse U.S. China relations that they developed a vaccine faster than we did, but weren't willing, or were putting us at the back of the line because of where our bilateral relations were. That it would be a massive threat to the American security and well-being, just at the literal level of our lives and our economy. And that's not a position the United States ever wants to be in, and which is why I think it's encouraging that we actually have a president right now who's talking maybe more than any president that I can remember about the importance of developing domestic pharmaceutical capacity and manufacturing. Now, it's easy to say that, it's hard to make that transition. You can't snap your fingers. But yeah, so I think it's just worth reminding everybody that biotechnology is not some fanciful, futuristic thing. We all benefit, presumably most of us have already benefited from it. The entire economy benefited from it in the world. And it wasn't an accident. It was the result of long-term investments that the U.S. government has made through NSF, through NIH, DARPA, precisely. And so, you know, it's not an accident that we were the country that produced multiple leading-edge vaccines in record time. But anyways, but that actually is a good segue into thinking about strengths and weaknesses, right? The United States, I think we assess in our report, and you guys do as well, that right now we have a sort of clear but tenuous lead in emerging biotechnologies vis-a-vis China. And so maybe you can just do a little walk around in terms of some of the top-line reasons why the United States is in this position. And you also talk about in the report, which I strongly encourage everybody reads, it's excellent. You know, if we lose our edge, we may never get it back. And so what are some of the reasons that we have the edge, and what are some of the reasons that we are at risk of losing them?
Yeah, absolutely. Well, I'll just say, and far be it for me to correct you, but I think our diagnosis is a little more nuanced, which is in the aggregate, yes, the U.S. has a tenuous lead, but a lead. But when we look across different metrics, like what adds up to that, there are places where, even a year ago, when we put out our interim report, we said China is sprinting to close the gap. Now, what we're saying, and this is a result of both technological developments as well as policy developments, there are clear metrics against which China is beginning to exceed the United States, right? So some of the metrics that we looked at were things like capital, manufacturing capacity, talent, IP, research, highly cited research papers. One of the things that even has changed just in the last couple of months since we went pencils down on our report is things like U.S. companies licensing Chinese biotechnology, biotech innovations. Those are the things that drive us towards a conclusion that yes, sure, we are very good at biotech in this country, and I can get into the reasons why. But 20 years of strategic prioritization across not just their government but their private sector in China is starting to show results. So when I sort of look at the assessment, one of the strengths in the U.S. system, of course, is our capital markets. But you talked earlier about this sort of biotech community not necessarily seeing itself as one cohesive unit, and part of that is that the paths to market, the paths to exit for investors in the biopharmaceutical sector are fundamentally very different. It's a very different economic model than in the industrial or agriculture or other types of applications of biotech. We still see far more private sector investment in biopharma than we do in other sectors. Part of that is a regulatory issue. We can work on that. We have a prescription for working on that. And we have some of the best and brightest and smartest and most dedicated people here in the biotech ecosystem, whether that's working in the U.S. government or in research institutions or out in industry, all of whom want to solve hard problems in biotech and with biotech. And that has really been the engine, the people, I think, and the discoveries that they have made have been the engine of innovation and leadership in the U.S. That's starting to change, I think. We are, but let me just pause there and say, like, on the China side of the ledger, quite strong in manufacturing capacity. Very assertive about attracting that talent to China, whether that is Chinese students who come and study here in the U.S. and return home with what they've learned, or increasingly attracting and retaining American, Western, leading edge scientists. Increasingly good at on sort of like an innovation and research metric. We look at highly cited research papers or things like these out licensing deals. So it's we still absolutely have some major strengths here, but not because we have been, as a government, making this a strategic national priority for 20 years.
I think what's true for biotech is true for a lot of emerging technologies, and sort of when we think about relative strengths and weaknesses for the U.S. and China, there are virtues to basically Washington paying very little attention to biotech, for better or worse, in that we have a very innovative sector. We have an extremely highly capitalized and dynamic private market. But the downside, at least on that point, is you mentioned how even though the United States, like if you ask people around the world what they wish they had to jumpstart their biotech sector, it would be America's capital market, right? And our relative sophistication and understanding the biotech sector. If you talk to European VCs or ones in Asia, they're just not, because we have hubs in Massachusetts, in the Research Triangle Park in California that are co-located with capital centers. And so there's just a greater familiarity with the industry and therefore a willingness to invest in what is in some cases a higher risk long-term investment. So as a result, we're able to funnel capital into the biotech sector more than a lot of other countries, private capital. With that said, it's still chasing the most likely return because it's a private investment and it's overwhelmingly flowing to the health and pharma side. That's good, we need health and pharma, but you mentioned some of the other sectors that are not getting as much capital as a result. Just to be more specific about it, I mean, we're talking about companies that might be making the defense applications that you were mentioning, Caitlin, right? The armor for soldiers based on spider silk that might be lighter and more durable, that gets talked about a lot in this context. The replacements for synthetic chemical inputs for explosives that the DoD needs, that all of a sudden we realize in the context of a conflict or escalating tensions we can no longer source, or we can't source it at the level that we want to. All of those things, you know, but they're not necessarily getting the private capital because the return isn't there. Energy, agriculture, manufacturing generally. So as a result, we're very strong on some sides, but underdeveloped in the other. Whereas the flip side of that, of course, is in China, it's overwhelmingly state capital, and as a result, they're able to brute force their way into not your way, but they're able to brute force their way into a leadership in areas like synthetic biology, you know, biofuels, biological engineering. I think ASPE has done some really good research and tracking in terms of technological. And you're right, it's not as clear cut as we're clearly in the lead and they're behind. It's more nuanced. I still think on balance, I would rather play America's hand than China's hand, but we're not really playing a hand right now.
We have to play the hand.
We have to play the hand.
We can't just like hold it and go, oh yeah, we used to be good at this.
It's, you know, you mentioned you're writing your report before you were pencils down. When we were working on our report, you know, when we were identifying strengths in the United States, you know, talent, capital, allies and partners, domestic, you know, a research, like world-leading research institutions that are private or academic. And in one way or another, I hate to say it, but in one way or another, we've actually, I would argue, in the last few months, undermined a lot of those strengths, and we can talk a little bit about that later. But I hope it's just a temporary thing. But one thing I wanted to dig into a little bit with you, Caitlin, is we haven't really talked about biodata, and you guys have a great section in your report about biodata. Maybe you can explain, because we don't have, you know, bioscientists and all here, what that even means. And you know, our report assesses that this is actually a big disadvantage of the United States, that China in some ways has an asymmetric or structural advantage when it comes to biodata compared to the US. Can you just talk a little bit about it, whether you agree?
We came to the same.
And then let's think about what we should do about it.
Yeah, sure. Okay, this is the part where I try to convince you that biological data, which is not a thing that most people think about day to day, really fundamentally matters here. I am not a scientist either, so this was a learning curve for me, for sure. If you think about, we spent a lot of time thinking about the convergence of biotechnology with other tools like AI, ML, and automation. And we did that because we really think that convergence and the use of AI in the biotech sector is what is going to power a ChatGPT-like moment for biotech, where, you know, like I said, historically, innovations have been the product of, you know, decades of work, maybe whole careers of work. And now, you know, with these tools applied to biotech, that time scale and the cost associated with it is rapidly shrinking, so that we can start to see lots and lots and lots of really exciting innovation on a much shorter time scale and much less cost. So if you think about how, you know, LLMs are powered with the English language, like that is the data that, you know, powers actual ChatGPT, not biotech ChatGPT. It's exactly the same analogy into biotech and how we use AI. The AI models for biotech are called biological design tools. They are powered with biological data. Sometimes that's human related data, but a lot of times it is things like how we understand how proteins work, or how we understand the genetic information of flora and fauna, non-human genetic information. I guess it was last year, year and a half ago now, a team won the Nobel Prize on the basis of work that they did with a model called AlphaFold. AlphaFold fundamentally changed the way that we understood how proteins work and also drove innovators towards novel protein design. So these are things that don't happen in nature, but we can use this convergence of the AI and biotechnology to make new proteins. That was on the basis of a database called the Protein Data Bank. And over decades, researchers had been contributing to the Protein Data Bank largely on a voluntary basis, with the understanding that this is the kind of information, what's called proteomic information, that was going to power this kind of really exciting new model, and therefore all kinds of discoveries out of it. So now we're seeing people use AlphaFold to design new drugs that we really couldn't have imagined without that tool. A lot of our best biological data here in the U.S. is held, proprietary in private sector companies. That's appropriate. That's one of those things that actually makes sense in the U.S. hand. But we also have really exciting stores of biological data in USG hands, and we're not taking sufficient advantage of those. They're not well curated. They're not particularly accessible to researchers, and we also have a lot of flora and fauna and biological information just out in the natural world that we don't particularly understand. So let's go get that data. And
you should talk about that. I think one of the best or most exciting recommendations in your report. Yeah.
Okay.
To that
so
effect.
Here's the thing. This is the thing I didn't understand either. But a lot of our drugs, the ones that you'll be familiar with today, whether that's penicillin or Ozempic or whatever, are derived of a phenomenon in the natural world, right? This is something that penicillin is a bacteria it's a fungus, right? Yeah. Angie would, maybe Hannah can help me. Angie on our commission would debate whether it's a bacteria. Anyway, point being. We derive a lot of medical innovation from our understanding of the natural world. One company that works in this space described this to me as if you think about the wealth of biological information, genetic information about just non-human flora and fauna as the oceans of the world, what we actually understand is an ounce. That is human understanding of the natural world is an ounce, the genetic information of the natural world. So one of our recommendations we call the Public Lands Sequencing Project, and the idea here is that the Department of Interior, working with the private sector, will sample the flora and fauna of U.S. public lands and then sequence that information and drive it into this other idea that we have, which is the web of biodata, which will be a U.S. Government-led effort to really treat biological data as a strategic national resource and make it available to researchers easily, well-curated, able to pull from different databases. And our goal through the combination of those things is that researchers will be able to focus on deriving innovation on top of that data rather than the creation of data to drive their innovations.
Yeah, that's really exciting. I mean, I think this is one of the issues in getting back to the pros and cons of a very decentralized approach to biotech leadership that we've had in this country, is that we have a massive amount of private sector innovation that's been leading to an abundance of digital information, and a lot of it's biodata. When we think biodata, we think, okay, health data, but I think you've helpfully reminded us that it's a lot of environmental data related to flora and fauna and plants and animals. And oftentimes the combination of all of these things will yield insights that we're not even aware of now. Yeah. And I think as machine learning and AI tools improve, the possibility of that only increases. But the issue is because we have really no national strategy for biotech, all of the, when we think about even just the migration, sort of encouragement of medical health records and electronic health records in this country, we've sort of nudged the clinics and hospitals to make this transition and encourage them to be interoperable. But anyone who's spent any time in the healthcare system knows that it's a total mess. And we have, this is on the private side, we have a lot of medical data, but none of it really speaks to each other. They're all processed differently, secured differently, the intake is different. And so it's like a bunch of, it's like we're sitting on a massive gold mine that we can't quite use. And also we have to be careful about how we use it because it's people's personal medical data. And we aren't the CCP. We aren't just going to take people's data in the country and outside of the country, which is something that Wuxi and others have done. I would argue, using some sort of shady business practices. To amass a lot of biodata. So I think the opportunity for the United States is how do we take the wealth of biodata that we have, including in the federal government, honestly just the biodata in the federal government that resides within NSF and NIH and DOD. And we even imagining that the Department of Interior and the U.S. Forest Service and all can be enlisted to survey and collect these resources is an extraordinary opportunity. But it's going to take resources, it's going to take a mandate, and it's going to take the infrastructure to put it all together. And there's no reason we can't do that, but it will take leadership and resources. And just to put another foot stomp on it, China does have policies to mandate the digitization of their health data, to migrate to electronic health records in a much more systematic way, to build large-scale databases for their biodata. They understand this, right? And they've been spending a lot of time taking biodata from their population and from populations around the world. And this is going to be a growing disadvantage of the United States over time unless we do something about it. And the United Kingdom has done some really interesting work around a UK biobank, which is sort of a quasi-governmental organization to help sequence and amass biodata on a voluntary basis that researchers can then access. And I think the proposal that you guys have for a web of biodata could be a real interesting way to fill that gap. But one thing that I worry about, because our team also does work on AI, a lot of work on AI, you mentioned AI, and this is something I'm giving some thought in real time to right now, so I'm just going to test it now. But I worry that our inability to fix the biodata problem that we're describing is going to not only inhibit our bio leadership, but our AI leadership, because we have a ton of data that is not AI ready, right? It hasn't been labeled, it hasn't been cleaned up, it hasn't been curated, and that is, as are these LLMs have basically scraped up everything they could scrape up from the internet, they're going to need high quality sort of specific data, and biodata is one of those areas, and we are just not making it available for a lot of our frontier models to use responsibly, I should add, which they would need to use. And that's going to limit their capabilities. And then, of course, the slowing down the development of AI models on the one hand will prevent us from using those models to drive biotechnology insights on the other. So these things can be working together synergistically, but it requires vision from this town that you guys have provided, but I think hopefully will get picked up a little more. So one thing I did want to mention on that note, Caitlin, is Caitlin and I are both recovering Hill staffers, and you guys are been stood up by the Hill, and you guys are working, your commissioners are all members. How has this been received on the Hill? What are the next steps in terms of implementation and some of the specific recommendations you see getting carried forward?
Yeah, absolutely. So taken together, the commission makes 49 recommendations, which sometimes when I say people go like, oh, eye roll, that's a lot of recommendations, how are we going to do all those things? But it is roughly an even split in support of a two-track strategy to run faster and slow China down. And our commissioners feel really strongly that we need to be able to do both. We can't outrun, and we can't just use protect measures to slow down. We have to do both things. The bipartisanship and bicameralness is built into the construct of the commission. Senator Young, as I mentioned, is our chair, but we also have on the commission Senator Alex Padilla, Representative Stephanie Bice, and Representative Ro Khanna. And then the remainder of the commissioners were appointed on a bipartisan basis by leadership from both chambers. So inherent in the work was a push and pull between commissioners about what would solve these problems, and also what would policymakers act on in an urgent way. And we think we've come up with a playbook that does both things, right? That really, in total, our recommendations amount to a $15 billion investment over the next 5 years. Sounds like a lot of money, is a lot of money, but is far less money than we would have to spend if we did this 10 years from now to claw back this ability to lead in biotechnology. That message seems to be resonating with policymakers. I think they are increasingly appreciating all of the myriad, possibilities of biotech. The message around job creation and sort of the opportunity to leave on the table, jobs that would benefit all states and districts. We have another 18 months of work before the commission closes its doors, and our goal is that we will write legislation against most of these recommendations, and we'll work with members of Congress, including our own congressional commissioners, but others too who have raised their hands already to be champions in this space, to move these initiatives forward legislatively. We did not want to just observe the problem.
Yeah.
We wanted to offer and we also didn't want to just offer a playbook. We want to work hand in glove with members of Congress on new legislation, oversight of existing programs, and appropriations needs, so that when the commission closes its doors eventually, we have a cadre of champions who are moving this forward. I will say, just to take us full circle, I do think that among all of the things that policymakers have to worry about, that lawmakers have to worry about, our former bosses have to worry about every day, even just in the sliver of that is technology policy, our job and those that agree with the things that we found is to raise the level of prioritization of biotech in that tech stack, and to raise the level of what we call bioliteracy among policymakers, right? So the last the last biology class that I took was in high school. I think that's pretty common among Hill staffers. I don't know when yours was. Maybe it was sooner.
Yeah.
But that can be kind of a barrier, right, to action in this space, is the sense that, I'm not a scientist or I'm not a biologist, and I'm never going to understand the technology deeply enough to be effective at making policy around it. And there is a place in this battle for biopower for everyone, whether you are a deep subject matter expert or someone like us with liberal arts degrees who become bioliterate, right? I use the analogy of like a computer. I don't know how my computer works, but I know how to use it, and I know how to use it safely. Like that is what we should be striving for with respect to education and information around biotech for policymakers, is like, let's equip our leaders with the tools to understand enough about how this technology works to make effective policy, and then also empower them with subject matter expertise.
Yeah, great. I'm realizing I'm selfishly asking all the questions and I haven't. Oh, well, I guess we're getting the time is up signal. So let me ask with. So I'm sorry, audience, I didn't even get to ask your questions here, but I'll take a mea culpa for that. Let me take one more question, which is, if you could leave this audience, in person and online, with one takeaway from your report, what is the most important thing you want to leave them with?
Sure. There is time to act, but no time to wait on biotech. We are not yet in a situation where we have lost, but we are not squarely in a comfortable leadership position any longer. There are discrete actions that policymakers can take, whether that's our playbook, your playbook, somebody else's playbook, but like, let's play the hand we have.
Yeah.
If we wait longer, even a matter of a couple of years, we will lose in this technology sector in a way that we will never be able to recover.
Thank you, Caitlin.
My pleasure.
We have time to wait. We have no time to wait. Time to act.
Time to act, no time to wait.
Okay, I'm going to put that. That's going to be.
You could get a tattoo. I'm thinking
I think
about
I'm going to have to get a tattoo. Yeah.